All right, class, we're going to go over some concepts about area, okay? An area is the amount of two-dimensional space that something takes up. Now, up to this point, we've been talking about the perimeter. What's the perimeter again, Melina?
The area around the shape, how much it is.
All right, not the area around though, it's the line. So what do we write when we're finding the perimeter? Do we write like feet and inches and centimeters, or do we do feet squared, inches squared, or centimeters squared? Do we use square units for perimeter, or do we just use linear units, they're called? Well, when you labeled the perimeter, did you just label it feet? Like so many feet around? Yeah. These are not square units, they're just a line that goes around the figure. Okay? Now, with area, you have to talk about square units. So look at this example. If we were to estimate the area of this heart, and each square represents 1 inch squared, then how could we find the area? For these irregular figures, what would we do?
I mean, you could like take the squares and let's say each square was a certain amount,
And we know what the amount is. It's
yeah, it's 1 inch.
1 square inch.
Yeah, and then you could
Just simply do what?
count them and count
Yeah.
them. And some of them they aren't whole, so I don't know what you do there.
So then just count the fractions of them,
Yeah.
the parts. So if we estimated this, count all the whole square inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then we could just count halves, since we're getting an estimate. Okay? So, this is 2 halves, so that's another 1. So that would be 20, right? 20, 21, 22, 23, 24, 25, 26, 26 and a half, or 27, somewhere in there, right? So just by counting the area, the square units, you can estimate how many that is. And for irregular shapes, that's really the only method we have. All right, or unless we were to put it on a grid and do some calculations. Take a look at the problem solving. I think you get the idea for these, for just counting the squares, the number of squares that it takes up. And it's just an example of what area is. Area is the space that it takes up. Think about carpet. When you're laying carpet on a floor, you are laying carpet over the entire area, not just in the perimeter, but over the entire area. Number 4, the drawing shows an outline of a pond that is being constructed in a city park. Each square represents 10 meters squared. Estimate the area of the pond. So now we're not counting 1, we're counting by tens. All right? So each square represents 10 meters squared, or you could count up the squares and multiply by 10. Number 5. The drawing shows an outline of a community garden. Each square represents 5 feet squared. So what can we do with that one? Instead of multiplying by 10,
Multiply it by 5.
yeah, count up the number of squares and multiply it by 5. Okay.
The full squares, or just full squares and then multiply it?
The full squares multiplied by 5, and then figure out how many parts you have to make a whole square,
Oh,
so that you multiply those by 5 also. So if you have 2 halves, you can make a whole, and then multiply that by 5. Okay. Put your pencils down a second. Number 6. What is the best estimate of the area of the shaded figure? What do we have to assume for this one? Does it give us a scale for the squares? Or what are the squares? The squares, it just says are 1 square. We just have to assume that they're worth 1 square unit. Okay? So it doesn't give us a scale like these drawings. So those are just 1 square unit. Alright? Any questions on that? Okay. I want you to do 4, 5, 6, and 7 for homework, but put your pencils down, because we are also going to talk about the area, how to find the area of these figures. Squares, rectangles, and triangles. Okay, we're going to review this as well. So, these are figures that we can apply formulas to, because we know, for example, that in a rectangle, the base and the height, or sorry, the 2 lines on the top and the bottom are the same. It has 4 90-degree angles. And so because of those properties, we can use a formula. The formula is area equals length times width. So if you know the length, you can find the length and width, you can find the area by multiplying the 2 numbers.
oh yeah.
Okay? On a square, since the length and width are the same, you would be multiplying the same number times itself. So the formula is area equals side squared. The length of a side times itself. S squared means S times S, or side times side. Since they are the same, it's the same number. And then finally, the triangle. And the area formula of a triangle is length times width, or base times height. These are the same types of dimensions, and just using different letters. The base is always perpendicular to the height. On a triangle, that's not necessarily the lines that are creating the peak, because those lines are slanted. So the height is an imaginary line that goes from the base to the peak of the triangle. Alright? And so on a triangle, you have to use what's called that altitude line. The line that goes straight up from the base, or creates a 90-degree angle with the base. Okay? So you want to look for that square, or look for that 90-degree angle, and then use that measurement to calculate the area. Let's do a couple of these together. Number 1 is a square. So to find the area, we would do what? Raise your hands, quick. If you know, raise your hands. How do you find the area of a square? Maya?
Would be 12 times 12.
Good. 12 times 12, or 12 squared. 12 times 12. Base times height, or length times width. On a rectangle, to find this area, raise your hand if you know. Danny?
Length times 2 and width times 2 and you add together.
Oh, that's for the perimeter. The perimeter would be the 2 times the length plus 2 times the width. But since we are going to find the space that it takes up, we have to find
5 times 22.
5 times 22. Yep. Length times width. 5 times 22. Let's review. How do you label area differently than you label perimeter? You label it using what kind of units?
Square.
Aiden?
Square.
Square units. So we would write 144 yards squared. We have to write the dimensions, or sorry, the label with the 2, the 2 exponent, the squared exponent, because we're talking about square units, the little squares that we covered in the last, in the previous page. Let's do number 3 quickly. Which dimensions do we use to find the area? For a triangle, how do we do that? 1/2 times the base times the height. So what numbers should we use? How do we put this together to find the area? Why don't you start by multiplying base times height? So the base is 17. The height is 9. Because that's the dimension that is the line perpendicular to the base. Creates that 90-degree angle. But how do you multiply by 1/2? What's another way to multiply by 1/2? Cut it in half, or divide it by 2. You can multiply it by 1/2, or you can divide it by 2. So finish this worksheet for tomorrow also.
The whole thing?
Yep. It's the whole thing. It's just 4, 5, and 6. Okay. No, don't use a calculator. It's only 3 questions.